Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this particular video we will talk about the implementation of decision tree algorithm. I hope that before coming to this video you already have watched my previous video where I have clearly explained about the mathematical aspects like how we can do the calculation via the Gini index and then via the entropy. Please do watch those two videos. Those are the prerequisites to attend today's video, right? Because today's video is just the focus on the implementation part. So what we will do is we will try to use the wine quality-red.csv dataset where we will try to do the prediction on the quality of the wine depending upon the features that we have. Don't worry, I will show you everything via the implementation. So please stay tuned and watch the video till the very end so that you will, able to get the idea that what I clearly want to explain in that video. So let's get started. So now let's start the implementation part where for the sake of the implementation of decision tree, we are using something called as wine quality red.csv file. Now I hope that you all are aware about this particular dataset where we will be having a set of features, and on the basis of that on the features we will be having a target column called as quality, which is basically used to predict the quality of the wine depending upon whatever features we have. So I'll show you the complete dataset also within a few minutes. So let's get started. First of all, let's try to do the import of all the required packages that we really need. So what I will do is I will try to import all the required packages, right? So, or the libraries you can say. So let's start importing that. For example, we need pandas as an PD, we need NumPy as an NP, we need matplotlib for the plotting purpose, .pyplot as PLP, right? We need cborn as SNS. Make sense? So here the focus is just for the implementation of decision tree. So I will not do much on the EDA perspective because I hope you already have watched my videos of EDA in the machine learning playlist itself. I do have. But here the focus is just on implementing the algorithm part. Okay. So make sure that you will focus on that aspect itself, right? Now, what we can do as a second step is we will try to read the data set. We will try to read the data set. Now, I hope everyone is aware of the fact that how we can read the data set. So we can say data frame, which is equals to pd.read underscore csv. And here what I can do is I can give the path of my data. So I will copy the path and I will paste it here. Okay. And after that, we can just check what are the topmost 5 records that we have in this particular data frame. So now here if you will observe, we will be having fixed acidity, volatile acidity, citric acid, residual sugar, and so on until alcohol. All these are the features of the wine that we have. And if you will observe at the very end, we will be having something called as quality. Now this quality is something which you can consider as a target column which we really want to predict. Now if you will see, if I will say what are the features that we have, you can say data frame dot columns. How many number of columns do we have? What are the values we have? So all these are the columns that we have, which we can say feature, except the last value, which is the quality. This quality is the target one which we have. How many different set of qualities we have in a wine quality data set? You can say maybe set of data frame of, you can just say quality. And here you can mention that how many unique quality values we have. So here you can see that the quality is either 3 or 4 or 5 or 6 or 7 or 8. Depending upon what kind of features do we have, what are the values of the features that we have, we can predict that the quality either belongs to 3 category, 4 category, 5 category, 6 category, 7 category or 8 category. It means it's not a normal classification problem. It's a multi-class classification problem. Can you see that? Because it's not a binary one where I have to predict whether the class belongs to 3 or 4. It's kind of a multi-class classification problem. Perfect. Now, what I will do is, as I told you that I will not do the EDA part here. I'm directly moving towards splitting the data into, I would say X, which indicates the independent features, and Y, which indicates the target column. Okay. So what we have done here is we have split our data into two parts, X and Y. So what we can do here is X is something which is equals to data frame. And in that data frame, what I will do is I will completely remove that target value that I have. Okay. So what we can do here is we can say data frame, we can say drop. What is the column name which I want to drop? The column name is equals to quality. And I want to drop it column Y, so X's will become equals to 1. Make sense? So this will become X. Now Y, which is the target value, is equals to data frame, and in that the column name is quality. The column name is quality. Make sense? So now here if you will observe, if I'll say X dot columns, you will be able to get that X contains the columns except the last value, which is what I really want because all those are the independent features. And Y, which is small y I am considering, contains only the target column, which is the quality value. Okay. Now let's start the process where first of all, we will try to split our data into training and testing part, right? So now the next splitting part will happen where we will split the data into training and testing set. Okay. So let's do that as well. So what we can do, we can say X train, we can say X test, we can say Y train, and we can say Y test, right? And here we can call train underscore test underscore split. So we have to import that as well from scikit-learn dot model underscore selection, import train. I believe in this only our train test split is there. Let's see if I am wrong, we will be able to get the error. So here we will be having X followed by the value of Y. If you want, you can also mention the test underscore size and the random underscore state. I have already explained what is the purpose of all these values. But as of now, I am taking it by default. So let's split it into two parts, train and test, and it's done. It's done. Now we will be having a data set. We will be having a training set. We will be having a testing set. I want to apply a model. The model name is, so here what we want to do is we want to go for a data modeling phase where we want to apply, because it's a multi-class classification problem, we have to apply decision tree classifier. But as you know that this decision tree is responsible for the regression task as well. The only difference is that whenever you're solving a problem of regressor, in that particular scenario you have to call decision tree regressor. I hope it is pretty much clear to everyone. Now for this particular model to get to get selected, what we have to do, we have to do the import again. So what we can do, we can say from scikit-learn.tree, I want to import something called as decision tree classifier. It should come automatically. Yeah, it is coming up, right? Now what we can do is this model will be selected. Now once the model is selected, what we have to do, we have to fit our data into the training set. So what we can see, this model dot fit on the X train and Y train. So what we are doing is we are fitting our model into the training set that we have, and within few seconds this will be done. Now what you can do is, if you want, you can just predict the data, model dot predict, and here you can pass what is the X test you will be having, and you can store these values in the Y pred. So simple to do the analysis, right? So this model will give you the predictions. So this is something that you can say is the model predictions that you will be able to get. This is pretty much simple, right? But this is not something which I really want to talk about here in this session. It's quite simple. We have just imported our decision tree classifier. We have just fitted that. We are just able to get the prediction. And if you really want, you can create a data frame where you can see that what is the actual value, what is the predicted value. I think in one of the video I have done that as well. So if you really want to see what is the predictions I will be able to get, you can see that the predictions value will be in the range from 3 to 8. So you will be able to get the values of the quality of the wine depending upon the feature set that you are passing on. That's completely fine. I really want to look upon the complete tree, how my tree will look like, how my decision tree will look like. So what you can do, you can just try to do one thing here. From scikit-learn, you can just import the tree, and after that you can just make plt.figure, and here you can just mention what is the figure size you want to see in your screen. Maybe I want to see 20 comma 20, and after that I will say tree dot plot underscore tree, and inside that I will say the model that I have trained on, just that particular model, plot that particular tree on top of that, and I will mention the parameter of filled as equals to true, so that I want the filling inside that particular node, that what particular values I am trying to have in the node itself. So now what will happen is, you will observe the calculations also. You will observe that at every point of time what is happening is, the Gini value is evaluated, which I hope everyone knows what is it all about, because in the last two sessions itself of the decision tree, I have clearly talked about what is Gini index, how the value of minimum Gini index will be having a more priority to be at the parent node as comparable to the other nodes that we have. And after that, there is another parameter which we call as entropy, right? Now, if you will observe, this is the complete huge tree we will be able to get. I hope everyone can see my screen. This is the complete huge tree we will be able to get. Although you will not able to see the data inside this particular tree because the tree is very huge. What we can do here, we can try to maybe take a small set of samples and we can try to see that what are the values present inside that particular tree. For that, I can do one thing here. For you all, I can do one thing here. Maybe what I will do is, I'll take maybe 20 samples of data. Okay. I'll say I will be taking a sample data here, and I'll say that will be belonging to data frame dot head belong to 20 values. Just top 20 values I'm taking up, just to show you that the how the tree is being shown in this particular flow chart. Okay. Now what I can do, I will split my data, which is x sample, which is equals to I will be having. Okay, let me just show you first of all how this sample data will look like, and then maybe we can move ahead. So just for the visualization purpose, I am showing to you. So you can see that here now I will be having 0 to 19 number of records. In total, we will be having 20 records. So here intentionally, I am picking up top 20 sample data points from the data frame. Okay. This is what we are picking up. This is what we are picking up. Now, in this case, what we will do here is, in this sample data, I'll do the same task. I'll try to split it into two parts, x sample, which is equals to, we will take a sample data. We will take a sample data and we will try to just drop the value of what? Columns is equals to the quality value, right? The quality value. The quality value. And the axis is equal to 1, right? And now y underscore sample is equals to, we will be having sample data, and inside that we will be having something called as quality, right? This is what we will be able to get. So in this sample data, we will be having x sample and the y sample, and the task is done. Now, once the task is done, we will be able to get a sample model where we will apply the decision tree classifier, right? We will apply the decision tree classifier, and we will fit our model on the x and y. So we can say sample model dot fit, and here we will be having x underscore sample and we will be having y underscore sample. Once this is done, we will be able to get the data or the model that we have, which we call a sample model. Now what I can do is, I can just try to plot it down via the same code, but now not the model value, but the sample model value, so that we can just see that what is there inside the model. So what I can do here is, I can just copy it and I'll just write it down. Give me sample model. Now you will see what is happening. You will be able to clearly see what is happening. Can you see the values inside that? Can you see? I hope everyone can see this screen very clearly, right? Here, if you will observe, if I'll show you in this particular tree how many unique quality values we have. So what you can do, you can say sample data dot quality, and I want the unique value, so I will take set. Let's see. So you can see that either in this topmost 20 records, I will be having a quality value either 4, 5, 6 or 7. Now just let me open my Epic pen just to explain to you the point which I really want to explain here. Let me just go up. Okay. Okay. So here if you will observe, I will be having a values which is 4, 5, 6 and 7, right? Yeah. So what does it is indicating? Just try to understand. Here I will be having 4, 5, 6 and 7. So it is indicating that I will be having in the topmost 20 records which I have taken sample data, quality 4 is having only one sample. Quality 5 I will be having 14 samples. Quality 6 I will be having 2 samples. Quality 7 I will be having 3 samples. I hope it is clear to everyone. So for this value indicates that for corresponding to every particular quality, how many samples do I have? So in total we will be having 20 samples. Okay. Now how is this Gini is evaluated? I hope everyone knows what is the formula of Gini. It is 1 minus summation of I equals to 1 to n unique classes that we have, P of I whole square. So what is happening is, what is the probability of quality of 4? It is 1 by 20. So what will happen is, it will be 1 minus 1 by 20 whole square plus 14 by 20 whole square plus you will say it will be 2 by 20 whole square. So I hope it is clear to everyone what I am saying here. 2 by 20 whole square plus it will be you can say 3 by 20 whole square and bracket off. So basically what will happen is, for every, so if you will just solve this value, you will be able to get the answer as 0.475. So what is happening is, for every particular feature that we have, we are trying to evaluate the Gini value, and whichever is having a lower Gini value, that particular parameter we are choosing as the parent node. Now I hope you must have the question that what is this x2 indicates? See, if I just show you the columns, so if I'll just write sample data dot columns, so this is what we have, and if I'll just write x the sample that we have defined, x underscore sample dot columns. So you can see here, right? In this we will be having the features. This is the 0th index feature, first index feature, second index feature, third index feature. This is a list, right? This is a list where list is we can just get the value inside that list via the index number. So x of 0 indicates fixed acidity, x of 1 indicates volatile acidity, 2 indicates citric acid, 3 indicates residual sugar, chlorides, 4 indicates, fifth index indicates free sulfur dioxide, and so on. So basically what is happening is, because it's a numeric numbers, it's a continuous value, it will try to get the mean or the average of the values, and accordingly it will divide the values into two parts. So this x of 2 less than 0.4375 indicates what is the value present at x of 2. Just check that. It will be 0, 1, citric acid, right? Citric acid. So what it will do is, it will try to see, this is nothing but is equal to citric acid, which is having a lower Gini value among all the features, and how will it split? It will try to get the mean or the average of that particular value, so that we can split our data into two parts, where all the values less than 0.435 of that citric acid will go to the left side of the subtree. All the values bigger than 435 will be greater than, and it will go towards the right side of the subtree. So this is how all these four terms are pretty much important to understand in this particular tree. I hope I am able to give you the clarity how basically the tree structure is created. So basically what will happen, whenever we will be having, see, the example that we have solved in the previous two videos is the features that we have were of discrete type, yes or no. There are classes that we have, right? In this case, we will be having a continuous values. So for the continuous values, it will try to evaluate the mean or the average. After that, it will try to take the Gini value for every particular feature. Whichever feature is having a lower Gini value, for example, in this case, it will be having a lower Gini value. That's why this will be considered as the parent node. I hope, please, before coming to this implementation part, watch the previous videos where I have talked about the complete mathematical aspect. Now you should know how this Gini will be evaluated, how it is 0.475. I have clearly explained this class belongs to 4, 5, 6 and 7. So what you have to do, you have to calculate the probability of class 4. It is 1 by 20. For 5, it will be 14 by 20. For 6, it will be 2 by 20. For 7, it will be 3 by 20. So the formula will become 1 minus summation of 1 by 20 whole square plus 14 by 20 whole square plus 2 by 20 whole square plus 3 by 20 whole square. So the answer you will be able to get is definitely 0.475. I am not doing the calculation, but at your home, please try and let me know in the comment section that whether you are getting the same answer or not, which I am trying to convey here. Okay, so this is how the complete decision tree will be formed, and this is how completely our decisions will be we will be able to get, and we will be able to get the final answer at the leaf node. If you will observe in the leaf node, can I say this is the pure sample? This is the pure sample. Why I am saying this is the pure sample? Because if I am moving towards this side, the quality will always be 4. Here the quality will always be 5, right? Because all the samples are 0 apart from the middle one, which indicates 5, right? So always remember, the leaf node of any decision tree will be the pure node or the purest node where we will be able to get the final result, final output. Similarly, here if you will observe, it will belonging to 4, 5, 6, 7. So 7 is the output, right? Again, here also 7 is the output. So this is how basically we will be able to generate the decision tree via the implementation as well. So now here I have explained you both the aspects, that how you can generate the decision tree via the implementation and what's the internal meaning of that, and via the mathematical intuition behind that. Now, today's assignment for you all is just go and check it out, the decision tree classifier scikit-learn documentation. Scikit-learn documentation. Just click on that, go inside that. Now here you will see that for the criteria, we will be having Gini, we will be having entropy, we will be having log loss. By default it is Gini, and that's why if you will observe in the calculation also, in the middle steps, you will be able to get the Gini value, right? Gini value. Whichever is having a minimum Gini value, it is taking up that particular aspect. Similarly, splitter, we will be having a best or random. Max depth, we will be having int, it is of int type and default is none. Minimum sample split. Please try to go through this documentation where you should know every particular, feature value. Now, this particular parameters that we have in decision tree classifier, we have taken default, and that's why when you're calling this particular function, it is taking the default parameters which are there in the scikit-learn package library. But we can change that. Now the question is, how will I get to know that whether the Gini criteria is better or entropy criteria is better? In that case, the concept called as hyperparameter optimization came into picture. Depending upon what kind of data you are using, it can vary, right? It can vary. Maybe for some datasets, Gini is better. For some datasets, entropy is better. Now, in the upcoming sessions, I'll talk about something called as hyperparameter optimization, where I will show you that at what point of time, how will we be able to decide that which particular parameter is a good one for our dataset, right? But yeah, the objective of today's session is, I hope you will be able to get that point, how we can implement the decision tree classifier. If you have any sort of issue in terms of understanding of any aspect, whether it's a mathematical, whether it's a practical, do let me know in the comment section. I will for sure try to respond to you as soon as possible. With this, let's end today's video. If you find today's video insightful, please do share this video with everyone. Please do subscribe to my channel. It would really mean a lot to me. And with this, happy learning to all. Bye-bye everyone. And I'll see you all very soon in my next upcoming videos. Bye-bye and take care.